Hello, this is a brief demonstration of certain aspects of the M&M lab, and we're starting off with the first problem. As you can see, we have 4 M&Ms in here. Okay, 4 M&Ms. And what we're going to do is we are going to pour them out onto the plate. Now, this plate here shows 2 M&Ms with M's facing up and 2 M&Ms with M's facing down. Now, according to the directions, that means we are going to get 2 more. So I'm going to record that number. I'm going to reach into my jar of M&Ms here. I'm going to get 2 more. My boys have been into these M&Ms. That's why there's so few. So we'll go ahead and put them back in. And now we are going to pour all 6 out. Whoops. Let's try that again. And in this case, we have 2 more M&Ms. So that leaves 8 now. So I'm going to record that for the third trial. And then on the third trial, I pour out 8. And here I get 1, 2, 3 this time. So 8 plus 3 is 11. So I need to get 3 more. 1, 2, 3. Pour it out. And now we have 1, let's count it out. 1, 2, 3, 4, 5, 6, 7. So now we need 7 more M&Ms. Let me just get some here. 2, 4, 6, 7. Hey, how about that? So 7 more. That means that now we have 18 M&Ms. So we'll pour those back in. Pour out these 18. And then we count them up again. And we'll go ahead and separate them. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Looks like this one had the M rubbed off, so that's 12. I can barely see it. Okay, so 12 more M&Ms. Let's go. We got 2, 4, 6, 8, 10, 12. So I'm going to put that one back. 12 more M&Ms gives me 30. And this is my last trial. I'll go ahead and pour them in. And when I pour out these 30, I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I think that's all of them, so 12, and that would be 42. Okay? And so after that, what we're going to do is we are going to go ahead and plot these on a curve. We're going to plot this data on an axis, and we're going to see what the shape of the curve looks like. And then we'll come back and do the second part of the lab. Okay, now that we have completed the first part of the experiment with adding M&Ms, we are now going to plot this data, and we're going to build a mathematical model, or a function, if you will, that describes the behavior that we observe as far as patterns and things of that nature. So here are the trial numbers. Here are the amount of M&Ms that were put into each cup after each trial. And this is a plot of the points based on the trial number and the number of M&Ms that were added after each trial. So the total, actually I should say the total number of M&Ms. And as you can see here, we actually do have a very nice looking exponential curve. So if we come to the regression model stuff down here and we say, if we do a linear regression, okay, this is our line. We can see that it doesn't really approximate what it is we're looking at. But if I go to an exponential, that is very, very close to what we observed. A lot of the data is very close to this curve. So this, just by a quick eyeball, this is a good approximation to the behaviors that we see. And here you can see an approximate model that this red curve is demonstrating. And so we have 2.57 E. Now remember, E is that 2.71828182845 number, and this is raised to the 0.4 times x power. So if we wanted to get an approximation of, let's say, on our 10th trial, we would be approximately having 134 to 135 M&Ms showing up after we repeat this experiment. And this is essentially what those questions are asking you to do. This is where the tech comes in and kind of does a lot of the hard calculations for us. Okay, welcome back. Now we're going to do the second part of the lab, which involves taking a large quantity of M&Ms and going on ahead and pouring them out, seeing which ones have M's facing up, and removing them from this group. So again, we're going to pour these out. We're going to record the number of M&Ms that are face up, or M up, if you will, and then we are going to remove those and repeat this another 7 times. And after that's done, we're going to generate a plot, and we're going to generate a function, and hopefully we can identify the kind of function that we're seeing and use some technology to give us a mathematical model, an approximation, if you will, for this behavior of how the M&Ms are coming out. So let's get to it. So we'll go ahead and adjust my camera here a little bit, and we'll keep the focus on the plate. And as you can see, I have some M&Ms in here. We'll pour them out. And I have already counted these up. There are 45 M&Ms on this plate. So on our first pour here, we're going to go ahead and count up the number of that have an M facing up. So we'll go ahead and do that. We have 2, 4, 6, scooch these back, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now the yellow ones are a little hard to see. 19. I'm going to just put these guys off to the side for now so I can keep my pile separate. So we had 19, and so it's the yellow ones, that's 20, 21, 22, 23, and that looks about it. Let me just go ahead and double count this real quick. 2, 4, 6, 8, 10, 12, 14, 16, 18, 23. All right, so 23. So we're going to write that down on our first trial. We removed 23. The rest of these we're going to pour back into the cup, and we're going to do it again. And in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's all I see. So 10 on the second trial. those have been removed, and we're going to take these and put them back in, pour them out, repeat it again. We have 1, 2, 3, 4. So on the third trial, we get 4. Then we have 4, 5, 6, 7. So that trial there, we got 4. We're going to go ahead and pour them out again. And it looks like we have 3 on this trial. So on the fourth trial, we get 3 M&Ms a face, or M up. Here we get 1, 2. So we get 2 on the fifth trial that are M up. The sixth trial, we got none actually. And that's because it looks like 2 of these are duds. So they will never go M up. Let's just replace those with 2 that do have M's on them. Okay, that's good. So we'll have to redo that trial. So we got 1 with M up, and we remove that. That leaves us with 2 here. And here we also get 1 with an M up. Okay, I'll go ahead and put these back in my big jug. And essentially now what we're going to do is we are going to, let me go ahead and adjust my camera here a little bit. We're going to plot this data, and we're going to see what kind of curve or what kind of graph we're seeing that kind of mimics the behavior that we see going on here. What we should see in both cases, both part 1 and part 2, surprisingly, are exponential curves. So we're going to see if that actually pans out. I've mentioned on a few occasions that exponential curves are everywhere. And, exponential behaviors are definitely occur in many, many sciences, social sciences as well as physical sciences. So we've done just a simple experiment here, and we're going to determine if what I've been saying as far as observing exponential functions, observing exponential behaviors, if you will, actually pans out with this little experiment. So we'll see some charts and some graphs, and we will analyze and approximate and do all that math stuff here in just a moment. Okay, here we have a plot for the second part of the lab. Here is the data that is required to plot. Now, when we recorded our data, we had our trial numbers, and we had the number of M&Ms that initially got removed. The directions in the problem say that you need to record the number of M&Ms that are remaining. So this C column here in the spreadsheet represents the number of M&Ms that are remaining after I removed all of those that had an M facing up. So this is a plot of that data where the A column is the X coordinates and the C column are the Y coordinates. And as we can see, we have a nice little curve going on here. So again, if I try to fit a line to that, we can see that the line doesn't really do the overall behavior very well. It's just not the model that we want to use. So if I do a exponential, we see this exponential curve is very, very close to the overall behavior the data is trying to show us. And here we have an exponential curve going on here, where you have 38.9, if you will, approximately, e to the negative 0.5. So this is a decaying exponential curve, and that makes sense because if there's less M&Ms to pour out so they face M up, there would be less chance of getting a large number of M&Ms to face M up. So if I were to run this for an additional, let's say, 10 trial, just in a, all the way up to 10 trials, here Y gets to be 0.2. which tells us, and as far as the constraints on the problem are concerned, we could have all of our M&Ms face up or M up and be done, or we might have one still remaining to turn over. So this particular curve is a decaying exponential, basically starting somewhere around 38. And we start around 38, you can see that we're pretty far away from our data value here. That's mainly because of the way the curve is fit to the rest of the data. Notice we may be far away here, but we're pretty much right on the money for the latter half of the data values. So, we do try our best to approximate the overall behavior, but we do want to capture the essence of what the data is showing us, and the function merely gives us a mathematical representation that we can use later on, like for prediction, like I did down here for the 10 trials. So we are seeing exponential behavior in both cases. So this, again, gives us more support to say exponential functions really are all over the place. They really do show up everywhere. So the second part of the lab really starts talking about this. We take a function here and we do some other stuff to it. So if you don't have a graphing calculator available to you, you can use this in simulation and the information that we've got here to finish out the questions. Or if you do have a graphing calculator, I suggest you go ahead and pick up a bag of M&Ms and test it out yourself. Okay, you will see similar behaviors. I've done this lab many, many times. So just be aware that, here is an example, a very simple example, and we are still seeing exponential behaviors even with this simple experiment. So please believe me that exponential functions really do show up in a lot of places, and that's why we talk about them in class. So we're familiar with them. Okay, and this is essentially how the lab is essentially run. You can basically just answer the rest of the questions on the lab now.